8.1 geometric vectors, and a vector is basically any quantity with magnitude and direction, and the magnitude is essentially the length of the line segment, and the direction is the directed angle between the positive x-axis and the vector. So if you have a vector like this, PQ, the magnitude will be from here to here, essentially the length, and it will be denoted like that. And if you have it on a graph like this, again, the magnitude will go from P to Q, and the direction is the angle it forms with the x-axis. And since this point is at 0, 0, then it's said to be at standard position. So two vectors are equal if and only if they have the same direction and magnitude, like these two. And then they are opposite if they have the same magnitude in opposite directions. And then they're parallel if they have the same or opposite direction. This is the first example, and it is the magnitude of m is 29.2 meters, and the magnitude of n is 35.2 meters. If they're perpendicular, what is the magnitude of their sum? So to set this problem up, you want to go tip to tail, like this. And we will say that this is m, which equals 29.2 meters. And then this is n, which equals 35.2 meters. And since they're perpendicular, this angle right here is 90 degrees. And the sum of these two vectors is this one right here, the resultant vector. And to solve for that, you want to treat it like a right triangle. So what you would do essentially is, we'll say this is x, and to find x, use the Pythagorean theorem, and that is 35.2 squared plus 29.2 squared. So the magnitude of x equals 45.74 meters.
So this is vector operations, adding two vectors together, m plus n vector. So 5 plus 0, x1 plus x2, and y1 plus y2. So you get the coordinates of 5, -3. And then subtracting, you get 5 and -11. So unit vectors are the measure of i's and j's, which I is the positive x-axis, how many units it goes across, and j is positive y-axis, how many units it goes across. So you find the sum of unit vectors by putting these two vectors together, and then this is how you write the sum of unit vectors. So 2i goes across the x-axis 2 units, and 3j goes up 3 units, and then you get AB.
To find the resultant vector, we should go that way, and then the way we do this is we just move the 270 this way, like this, and then we make a right triangle, and we know this is 270, and then this is also 270, so we're just solving for this one. And then we can use the Pythagorean theorem, so it would just be 360 squared, plus 270 squared equals x squared. So x equals square root of a big number that I don't know what that is, equals 450. And that's your answer. So this is 450. And then now that you know that, you can solve for the angle if you want to. So the way you would do that, you would you have to use the law of the inverse of cosine or inverse of sine. So we can do inverse of sine. So inverse sine of x equals 270 over 450. And then you find what this is, and you take the inverse sine of that, and then you find what x is, and it should be an angle. And I don't know what that is, so. Next problem is similar to the last one, and you're trying to find what this line is, and the force of this line and the force of this line, given that the weight is 200 newtons going down. So the way you do this is you have to know two things. The first thing is that you should like move this one down, so and it's going to be the same as this line in terms of length or like newtons. So, and then the second thing is that this angle is also 30 degrees. And then this angle should be a 90-degree angle, making this a right triangle. So you can solve this by using the using sine or cosine, and then you can find the other side by using the Pythagorean theorem. So let's do this. So this to find this one right here, you can do so this one you can do sine of 30, which equals to this over this. So 200 newtons over x. And then you get 200 over sine of 30, which equals to 400. So this should be 400. And then if this is 400, this is the same, so this is also 400. So you already found what this is. Now you're trying to find what's the force on this side. So you can do that by using the Pythagorean theorem. So I'm just going to draw another triangle here. So we know this is 400, and we just found out that we found out this is 400, and we know that this is 200, and then you can solve for this. So Pythagorean theorem, 200 squared plus x squared equals 400 squared. And then you solve for, you just solve for x. And I don't know what that is, so I'm just gonna leave it for you to do it. That's it. Yep.
So how do you know whether two vectors are parallel? What you can do is you can find their inner product, and if the inner product equals 0, then you know that they're parallel. So what's the inner product? The inner product is, you can find the inner product of two vectors by multiplying them, and what you do is basically you take their components. So you have vector A, which is A1, A2, those are just the components of vector A, and you have B, B1, B2, which are both components of vector B. So you do A1 times B1, and you add it to A2 times B2, and you'll get the inner product. And if the inner product is 0, then you know they're parallel. So you can do the same thing to find the vectors in space, and it's just basically just a three-dimensional plane. So what you do is you do the same thing, except now you just have a third dimension. So you do A1, B1 plus A2, B2 plus A3, B3. And so just an example is if you have to find whether A and B were parallel, you can find the inner product by doing -3 times 2. And then you add it to 1 times 8. And then you do 1 times -2, and you all add those all together. And if it equals 0, you know that they're parallel. Thank you. So now we're gonna find how to find the cross product. So what the cross product is basically when you have two vectors, it's basically the vector that's perpendicular to both of them. So you have vector A, you have vector B. So the cross product of it would just be this vector going up in space, and it's basically perpendicular. You could just draw a 90-degree right there. So anyways, how do you find the cross product of two vectors? Well, you have this long matrices thing. It's basically a third order determinant. So I'll show you how to do that in a second. So you have this formula, but I'm just taking just an example. So you have the cross product of V, which is denoted by this, and then you have the vector W, which is 0, 1, 2. So you ask to find the cross product, and are they perpendicular? So what you can do is you can put V, you can put them into a matrix. So you have 0, 3, 1, and then you have 0, 1, 2. And now you can basically just use the formula. So you have A2, A3, B2, B3, so A2, A3, B2, B3, you put them in there, and just according to this, and from there on what you do is, you just do determinant, so you have to multiply these two, and then subtract it from these two, so you do 3 times 2 minus 1 times 1, and then you put an I there, which is just the unit vector, and then you basically do that for all of them. Just multiply them out, subtract, do all the work, and you should get 5, 0, 0 as your final vector. This is your cross product actually. And then come over here. So now we have to see whether they're perpendicular or not. And it's really easy. You just take your final cross product and you find the inner product of it, of the cross product and the original vectors you were given. So you just check, you find the inner product, and if they're both 0, then you know that it's perpendicular. Okay, I'm done.
So in order to find this, this is actually 8.5 applications with vectors. And in order to figure out this problem, they give you actually 2 sides, and they give you one angle that isn't actually the angle within the vectors that they find. So they give you the angle of 300, so that means that what has to be here is 60. And because you know the 2 sides, but you don't know the rest of the angles, you have to use the law of cosines, which is listed over here. And in order to put into the law of cosines, it's really just plug and chug. So just plug in 65, the 2 side lengths, 65 and 50, right here into A and B, and then continue doing that, and then you get the cosine. And then whatever cosine angle that you use, it has to be corresponding to whatever side you put over here. So as you keep doing it, you eventually get 58.95 as the magnitude. And really it's just plugging in equations and plugging in numbers in order to fit the law of cosines. Obviously, since the resultant vector is what fills in these 2 vectors, using whatever you found as the magnitude, you use it as one of the sides. So then you use the law of sines in order to figure out what that last angle, which is like right here, is, in order to find the direction of your resultant vector. So you just plug it into the equation given, which is x over sine x equals y over sine y. And then you just plug it in, and eventually you get the direction of 47.3 degrees.
To a Bobby Johnson beat.
Hey, word on the street, I'm a suspect.